lesson on nutrients, plant nutrients, and especially talking about the 16 essential nutrients that all living things need to survive. So we have here growing tomato plants, and just like you and me, tomato plants need to eat and drink to survive, right? So let's talk about the 16 nutrients that we need to survive. Now these are elements you find on the periodic table of elements, and when you break it right down to the basic form, there's 16 of them that if we are missing any of them, any of those 16, then we can't survive. So there's 6 of them that come in really large quantities, and let's talk about those first. So the first one I want to talk about is oxygen. So it's not surprising that you need oxygen. You all know how we get oxygen, just by take a deep breath, you just breathe in oxygen from the air. Plants can get oxygen the same way. Their cells do respiration as well. So in the cells of the plant, they do cellular respiration, just like I do respiration in my lungs, and then my cells do cellular respiration, and they take in oxygen that way too. So that's one way they get oxygen. We don't need to feed our plants oxygen because they can get it from the air. Another element that they need, just like us, is carbon. So we get our carbon by eating. So if you think about what we eat a lot of, one of the ways we get energy, of course, is eating sugar, carbohydrates. So sugar is made of largely carbon, also hydrogen and oxygen, so there's another source of oxygen there too. But unfortunately, plants don't eat sugar like we do, at least not most plants. There are some carnivorous plants, of course. You've heard of a Venus flytrap that actually eat their food, but most plants don't do that. So you probably know, though, how plants get their food. Their carbon, it's a big word, and you've probably heard it before, it's photosynthesis. So plants absorb carbon dioxide, carbon in the form of carbon dioxide through their leaves. Any green part of the plant is able to do photosynthesis. So that's carbon. And the other one, so again, we don't need to feed our plants carbon because they can get it from the air as well. And another one we get in large quantities is hydrogen. And I just mentioned there's some hydrogen in sugar. But there's, of course, also hydrogen in water. Water is made of H2O, and we drink water. Hopefully we drink lots of water every day. And as you probably know, plants need water as well, and they get their hydrogen by drinking water. So as long as I'm watering my plants, I don't need to give them hydrogen, carbon, or oxygen. Okay, so we've talked about carbon, hydrogen, and oxygen. There's 3 other elements that plants need in large quantities that they can't get from the air or from water. Of course, we would get them by eating a well-balanced diet. Well, plants need a well-balanced diet too. The things they need the most of, though, are letters that are elements that are indicated on the side of this bag here. So this is a fertilizer bag. We'll look at the fertilizer in a minute, but here's 3 numbers on it: 7, 11, and 27. So these 3 numbers are percentages of what's in this bag of fertilizer. The 7 stands for nitrogen, the 11 stands for phosphorus, and the 27 stands for potassium, so NPK. So this bag contains 7% nitrogen, 11% phosphorus, and 27% potassium. So by feeding this bag of fertilizer to the plants, I can get them those 3 ones they need. Now that's not a lot of nitrogen. And I actually use this bag as well. This is called calcium nitrate, or calcinite, and it doesn't have a number on it that I can see, but it contains mostly, as you can see, nitrogen. Is there a number on it anywhere? I don't see it. Anyway, so this has mainly the nitrogen source for the plant. It also, of course, has calcium, which is another nutrient we need to give the plants. So I said how many? 16. So we have carbon, oxygen, and hydrogen. We have nitrogen, phosphorus, potassium. Now I said calcium. Now we got to try to figure out the other 9. Okay, we'll do that next. Okay, so we have carbon, hydrogen, and oxygen from the air and from water. We're going to feed them large amounts of nitrogen, phosphorus, potassium, NPK. We have 3 others we're going to feed in large amounts. We mentioned calcium already. We also need to feed a lot of sulfur and a lot of magnesium. Okay, so what does that leave us now? That's 9. I need 7 more. Let's see if I can think of them all. So I know we need iron. That's an important one. Just like we need iron, right? We need iron. We need manganese. we need boron, moron, and chloron. Oh no, that's not right, but it's close to that. It's boron, chlorine, and it's not moron, but it's hard to say. It's molybdenum, and the symbol is MO, so you just say boron and moron. Miss Toth really likes that one, and I actually got it from our university professor, Tom Bauman, so don't blame me. Okay, so what's that? We also need zinc and copper. Did I get them all? Let me think. NPK, CHO, that's 6. Sulfur, magnesium, and calcium. We got iron, copper, zinc. We got moron, boron, and chloron, and manganese. I think I got them all. That's 16. All right. So I hope I didn't forget any, but you need to know those 16 essential nutrients for life. Now let's talk about how we get them to the plant. So we've identified our 16 essential nutrients. We know that these bags contain all of those. Scientists over the years have done a lot of research on what is the right amount of each nutrient to give to plants. You know, we want to eat a balanced diet, but we don't want to eat too much of this or not enough of that, or else we'd be unhealthy. So same with plants. So in a nice controlled environment like a greenhouse, we can control exactly the ratios that the plants get. So for starters, this is a pre-mixed bag of all the micronutrients and a few of the macronutrients as well. And in this bag, we know it's 7, 11, 27, we talked about that, but it actually tells me on here what ratio to mix that with this calcium nitrate to have the perfect formula for plants to grow. So it says here that if I mix, well actually it's kind of funny because it says for every 100 liters of solution I mix, for every 100 liters of solution, I need 115 grams of this one to go with 77.5 grams of this one, the calcium nitrate. So I actually need a little bit more of this to that, so there's a ratio there I can calculate. We just have a quick look at what these fertilizers look like in their granular form. Okay, so I got gloves on so my hands are protected, but you can see this is calcium nitrate, these white pebbles. It's just salt, right? And when just like salt, when I put it in water, it'll dissolve. Okay, so that's calcium nitrate. Here, this one I haven't mixed. Now this is a whole bunch of different nutrients. There's lots of different stuff in this bag. So, and it looks quite different than the calcium nitrate. So I'll just pull a little bit out here so we can look at it and you can see it's a very fine blue powder. All right, and that is going to be mixed with water as well. And we will have all the things we need for our plants. All right, we have 10 kilograms of calcium nitrate measured out in this bucket. Now, that's going to go with 15 kilograms of this plant fraud or hydroveg solution, and that's the right ratio. Now, we actually are going to mix them in separate bins. So if I can show over here, these are the two bins, and we can actually see what they look like. Inside the calcium nitrate bin, it's basically a clear solution when it's dissolved. There's a little bit left. So we're going to add 100 liters of solution to this tank and fill up the 10 kilograms of calcium nitrate. Have a look at this one. This is the micronutrients mix, and you see it's a very dark blue. Not surprising when you mix that blue-green powder with the water, it becomes very, very dark, and you can see that it's going to come up this hose and feed our plants. So we have to mix the bins separately, and here's why. If I was to mix this straight in with the calcium nitrate, instead of being a nice dissolved liquid like this, the chemical properties of the substances would basically make it form into a giant sort of a powdery solid at the bottom of the bin, and then it couldn't be taken up by these hoses and go into our plants. So that's why I need two tanks. We call this tank A for the calcium nitrate, this tank B for the micronutrients and all the other nutrients that we're giving it, and that way they don't form that solid, and by the time they get pulled up these hoses, they're diluted about 100%. So for every 100 liters of water going through these fertilizer injectors, we only have 1 liter coming up here from this tank. So it gets very, very diluted. It's kind of like having super strong, you know, iced tea mix that's like undrinkable because it's so much iced tea mix powder in it. And then you add a whole bunch of water, so it's a nice amount to drink. So that's what we want to do for our plants, is get the right amount. And the way we do that is with these fertilizer injectors. So we have to have the two separate tanks. Okay, so we've mixed our tanks with 100 liters more of water for both tank A and tank B. Now, that's the theoretical. Theoretically, we should have the perfect amount of fertilizer for the plants. Of course, we need to test it. We need to actually test what is coming out of our drippers now and into the plants and make sure that we actually have the right amount. So that's the next step. So I'm back over here now to my table. I've collected a sample of the fertilizer water here. As you can see, it's a slight bluish color. Not surprisingly, since our fertilizer was kind of bluish as well. But it's not as dark as the really dark concentrated fertilizer in the tank, right? It's been diluted now. So I have here an instrument called a multimeter, but basically the idea is it measures the nutrients that are coming in out of the drippers into the plants, feeding the plants. So this is a measure called EC, or electrical conductivity. The more salts or the more fertilizer dissolved in the solution, the better the water solution conducts electricity. So the higher the number on this reading, the more fertilizer I know is in the water. So I am, from the guides and from experience, I know that I'm looking for around 3.0 for an EC level going into the plants. Let's see what I get. Okay, I put the probe in there and I get 2.7, which is a little on the low side. It's not too bad though, very close to 3. So that's the first thing I need to check. Now the second thing I need to check is with this thing called a pH pen or a pH meter. So I have to take this cap off here. This always has to be stored in water. And I put this guy in here and I wait for that reading. And for pH, of course, pH is a measure of the acidity of the solution. And the acidity is very important. If I have the acidity wrong, the plant will not want to take the nutrients up. I'm looking for an acidity eventually between 5 and 6. So that's an acidic solution. These plants like an acidic environment to grow in. And it takes a few minutes for this to adjust, but I'm at just about 5.5, so that's pretty good. 5.5 is pretty well right where I want to be. We'll see, that takes a second to adjust sometimes, but I'm happy with that. If the pH was more like 6.5, what that would basically mean is it'd be kind of like the plants have a terrible stomach ache, okay? So you ever been sitting at a table and you've got all this delicious food in front of you, but you just feel gross and you have a stomach ache and you don't feel good? The food might be available, but you won't feel like eating it. And that's kind of what it's like for the plant when the pH is off. Having the pH right means the plant's feeling good, feeling healthy in a sense, and therefore it'll take the nutrients up that I'm providing for it. So, you know, if you're feeling good and you're hungry and the food's in front of you, you're gonna eat a lot, right? And that's what we want the plants to do, because if they're eating a lot, they can produce a lot for us. All right, so we're gonna finish this lesson off where we started with the tomato plants. So here we have a grape tomato, and you can see what I've done is I've actually rigged up this little apparatus here. This is just a piece of PVC pipe that I've cut in half, and it's made a big half pipe. And I've set my whole grow bag right on that, and as you might recall, the grow bags have a hole in the bottom. You can see some roots are actually coming out of the bottom, which is a good sign. That means the plants have developed a good root system. It also shows that as time goes on, I'll squeeze a little bit more out here if I can, and you'll see that this starts to just slowly drip into the water there, and you see the water's been collecting here. So I want that. I don't want the water to sit in these bags and it'll actually drown the roots of the plants. I want the excess water to leak out. This is also a great opportunity to do a couple things. One, I can measure, am I watering enough? I know that I measure that my nutrients going in was 3.0 or 2.7, close enough. That's right what I want. How about how much to water though? Am I watering enough? If no water was filling up this bucket, I would know that I'm not watering enough. Similarly, if this was pouring out continually, I would know I'm watering way too much and wasting water and fertilizer. So basically what I'm looking for is pretty much the same thing I put in terms of nutrients coming out. So I'm going to test my nutrient level with my meter here, so this won't fall, and let's see what I get. I'm going to test the over drain water, and you can see I get a number of 4.6. So 4.6 is actually a little high. That tells me that it's absorbing a lot of the water, and then a lot of nutrients are running out. Basically a high EC in the overdrain station like that tells me I probably should have been watering a little bit more yesterday when a lot of this water ran out, which actually makes sense because yesterday was a really, really hot day. It was 29 degrees in the afternoon, which means in here it was probably in the 30s for sure. And that means that these needed more water, and I don't have a system that allows me to adjust hot days and cold days. On hot days, I would ideally water more often, and on cold days, like today's a cloudy day, it's pretty nice in here. It's probably 24 degrees, 23 degrees, maybe even less. And I don't need to water very often. So today, I think my watering is probably just right on, but if it gets hot on the weekend, I really should turn the water up a little bit, or these could dry out. I just heard the water clicking on, so it's kind of good timing. You can see the water clicked on and my drippers just started dripping into the plants. They're going to go down into the roots, and then pretty soon though, a little bit will run into the overdrain station. Ultimately, if I can get 30% overdrain, I know I'm about right. So for every 10 liters of water that go into these bags, if 3 liters go into my overdrain, I know I'm watering the right amount. So that's a lesson on your nutrients, sort of what the nutrients the plant needs are, how to mix them, and ultimately how to measure and determine if I'm giving the plants the right amount. Hope you enjoyed the lesson.